Math. Lessons.
Hello, welcome to Free Maths Lessons. Today we're going to be looking at area of 2D shapes, okay? And in there we're going to be looking at area of rectangle, parallelogram, triangle, and trapezium, okay? And we're going to throw in kite as well, okay? So without delay, let's get started. So first we're going to be looking at the difference between the area and the perimeter. The perimeter is the length outside the shape. So you must have seen this and heard this in the TVs and movies, okay, where they're saying secure the perimeter. Secure the area. So this is the perimeter where you actually put the tape around it or put your guards around those area basically. So that perimeter is secure. Get the perimeter secure. So the perimeter is the length outside, okay? And the area is something that's within that perimeter, okay? So area is the space inside the perimeter. That's your perimeter. And what are the units do we use generally? We use the units like millimeter, centimeter, meter, kilometer, metric units. And when it comes to the imperial, means really old units, okay? Yards and miles. Not everyone in the world uses that, okay? So it's the UK and USA. Very few countries uses these imperial units. But those are the lengths that how you measure it, okay? If I ask you to measure my height, we're going to measure my height in feet and inches. Majority of the people in UK say their height in feet and inches. Whereas everywhere else, they say their height in meter and centimeters. So 1 meter and 66 centimeter or 1 meter and 70 centimeter or 177 centimeter. So that's how you actually measure the height, just measuring the length, okay? That's the perimeter. Measuring the length around the shape is perimeter. Whereas the area is slightly different, okay? Area is the space inside, this green parts inside the shapes, okay? That's the area. And how do we measure the area? We measure the area in small squares, okay? So if I have length in centimeter, height in centimeter, then I measure the area in centimeter by centimeter square. How many square can I fit in here? And what are the units do we use for area? Centimeter by centimeter squares, millimeter by millimeter squares, meter by meter squares. And if you're still using imperial units, and you can do the same thing, inch square, feet square, yard square, or mile square. So let's look at the area of this shape. How are we going to measure the area of this shape? So we're going to take these centimeter by centimeter squares and put it in here, okay? How many of centimeter by centimeter square does it take to fill this space here, okay? So if we keep doing that, we got 6 centimeter by centimeter square. So the length of that rectangle is 6 centimeter. So that length is 6 centimeter. And I can keep doing that and fill it in quickly. So you can see there are 3 layers of 6 centimeter squares, okay? 6 centimeter, and then the height here is 3 centimeter. So we can count those very quickly. The way to count them is using times table, okay? Times table is just repeated addition. If I add 6, then 6, then 6, I will have 18. 18 lots of 1 centimeter by 1 centimeter square. So the area of this shape here is 18 centimeters square. Formula means, how do I work out for area of any rectangle that I come across, okay? And it's generally going to be there. How many centimeter, meter, or millimeter is that base, or the length is. How many centimeter, millimeter, or kilometer that height is, okay? Which is the width. So length multiplied by the width, base multiplied by the height, width multiplied by the length or depth, whatever the things you want to say is the two lengths that multiplies together. How far across am I going and how far down am I going, okay? So those two lengths are multiplied together gives you the area. So generally when you're working out the area, it comes from base multiplied by the height. So you got the couple of more questions here, okay, that you can actually work with. Here, 2 meter by 4 meter. The length and the width of the rectangles, length and the width of any shapes to work out the area. When you're painting the room, you will come across saying, okay, we buy a paint. How much paint do I need to paint this room, okay? So they will tell you in the coverage section, okay, if I buy this can, which tells you 750 milliliters in here, but how much does it cover? So if I look at the carefully coverage here, 750 ml will cover 6 square meter. Okay, so I can cover 6 meter by meter square. 6 of these square meters covered by this paint. Okay, same here for all 3 of these questions. You can work it out. Okay, if I had 3 meter by 5 meter, I would have 15 meter by meter square. If it was 4 meter by 7 meter, I would have 28 meter by meter square. So what I want you to do is actually pause the video and quickly have a go at these 3 questions. And when you're ready, press play. And 40 centimeter by centimeter squares. And these are again real life questions. How much of the AstroTurf do I need if I need a football pitch? If I need to make a football pitch that goes 100 meter in the length and 50 meter in the width. So I'll do 100 times 50. Okay. And that will give me 5,000 meter square. I need 5,000 meter by meter squares to actually cover AstroTurf to play football on. Have a look at the other ones here. Okay. How much of the lawn seed do I need? There you again come saying, okay, if you buy one big box of the lawn seeds, you will cover 50 square meter or 80 square meter. So you can work out how many square meter there is and how many boxes of the lawn seed do I need to actually plant the lawn on the rugby. Or you probably need to buy a roll, ready-made rolls, okay? Same thing here. If I need to change the clothes on the pool table, how much of those do I need? How much of the card do I need to make those cards basically? I can look at the area. Again, the area of the rectangle is this length, which in this case 4. We don't know the unit, so we can say 4 units. Okay, and this height here, okay, again we don't know the units, so we can say 3 units. So multiply those base with the height, you get the area of the rectangle. In this case, we got 12 unit squared. Okay, whatever that unit is, those units squared, we got 12 of those. Okay, so the area of the rectangle is base multiplied by the height. And that's it. That's all there is. Now you can call base a length or a width. You can call height, length, width, or depth. It doesn't really matter. Okay, so those 2 things multiplied together gives you the area of a rectangle. Those 2 are identical parallelogram. That is exactly same as this one, and this is exactly same as that one. So those are 2 identical parallelogram. Okay, how do I work out the area of parallelogram? Okay, just watch and pay attention to small details. Okay, what am I doing here? I'm cutting that parallelogram at that point. Okay, where that finishes. The base finishes here. I'm going to cut it off at 90-degree angle. And what do you get? You get a rectangle. What's the base? Did we change the base of that rectangle? No. Base remains same. From there to there. In other words, I'm moving it there. Okay? There. That rectangle goes there. Base remains same. What's the height? Height is the same for both of them. Okay? Height remains same. So what's the area of this rectangle? It's the base times the height. So the area of the parallelogram is exactly the same way as the area of the rectangle. Base times height. Okay, here. Now the height needs to be 90-degree angle to the base. Okay, and generally we call that as a perpendicular height. So the area is really straightforward. Base times height. So pause the video and have a go at working out the area of these parallelogram. And when you're ready, press play. That's right. So these are the answers, and if you're making mistakes, make sure you look back and see where you've gone wrong. Okay, base there, height is there. Okay, base is there, height is there. They're making 90-degree angle. Remember, that's not the base. If you're looking at it, it's just going from that end to that end. They make perpendicular 90-degree angle. Okay, all right. So have a look at this one. Okay, that's a parallelogram. Okay, what am I doing here? Removing it, making it rectangle. So again, look at it. That length, the base remains same. Whether I have the rectangle, whether I have that one here, the base remains same. Or there. Okay, now that gives you a rectangle with the same base, same height. That's a parallelogram with the same base. We're not changing the area. All we're doing is changing the shape into a rectangle. So the area of the parallelogram is the base times the height. So that's the base and that's a height here. The base and the height. Again, let's make it that back into parallelogram. Again, area of triangle then. Okay, what is the area of triangle? Consider this a rectangle. How do I work out the area of this rectangle? We just looked at it earlier. Okay, base times the height. If I don't want the area of the entire thing, I only want the area of half of this rectangle. And when you half that rectangle, what shape do I get? I get a triangle. Okay. So when you do base times height, that gives you area of this rectangle. And when you half it, you get the area of this triangle. So the area of the triangle comes from half times base times height. They could write it like this. Base times height. Majority of the students that I come across, they always do base times height and then divide it by 2. Okay. You can do it that way. That's perfectly fine. But I prefer to write it this way. Why? Because let's say we got the base here is 10 and the height here is 5. So we can do 10 times 5, that's 50, and then divide it by 2 gives you 25. But I can actually use this formula here and work it out slightly better way. I can do half times 10, then times it by 5. Does it matter which order do you multiply? No, it doesn't, because multiplication is commutative. What it means is I can do half of 10 first and then multiply by the 5. Gives me the same answer. Half of 10 is 5. 5 times 5 is 25. So the area there is going to be 25. If the base is 10, height is 5. Okay, this triangle here. If you did this one, you'd half one of those things, base or a height. Half one of those and then multiply by the other. So have a look at this one here. That's a triangle, scalene triangle. Doesn't have any angle, that's equal. Doesn't have any length, that's equal. That's a scalene triangle. But again, we can work with base times height. Why? Look, I can put the parallelogram on top of that. That's the base and the height is from the base to the top of that corner. So that's why that's the perpendicular height. But what you notice here, this triangle here is exactly the same as this triangle here. Okay. So this is a parallelogram. If you put two of these, any triangle, when you put two triangles together, you can always make a parallelogram or a rectangle. Okay. So this is a parallelogram and the area of parallelogram is base times height, and I only want half of that, and that's why it's always going to be the half of area of parallelogram, and area of parallelogram comes from base times the height. So we get the area of triangle is always half times base times the height. Pause the video, have a go at these questions, and when you're ready, press play. Whenever you're doing these, be careful of the units. And you're always doing base times perpendicular height. None of these slanted height. The height of this triangle is, if I extend that base from there to there, that's my height here. Okay, that's the height. If you extend that base, so perpendicular to the base is height always going to be 90-degree angle to the base. Okay, and don't forget the units. If the units are in the different, so centimeter and meter, make sure you convert them before you actually answer the question. Okay, that's another key thing you always have to keep in mind. Area of trapezium. Okay, there's a two different way you can do this. Area of trapezium. One, you can have the same exact trapezium and turn it around and makes a parallelogram again. Exactly the same trapezium, turn it around, makes a parallelogram. Or you can do this, cut it into half and put it next to it. And that also makes a parallelogram. Okay, and we know the area of parallelogram is. So have a look at that. I cut the top half and put it on top of that. Okay, so that's the parallelogram. And now if I'm cutting that top part and turning it down here, that top there, A, goes to that A. So the length of the parallelogram comes from adding the two parallel lines. Okay, and that's the only property trapezium have. Any trapezium will have only property, it has one pair of parallel line, okay? And that doesn't have to go horizontal, it could go vertical. That's a trapezium. And it has this property because one pair of parallelogram, A and B. And that's the reason we add A and B. Because you get, even if you turn entire trapezium over, get a copy of it, put it on the other side, then you still get the length A times B. Sorry, A at B. That length goes at the bottom here because you're putting it upside down there, okay? And then you're multiplying by height because the area of parallelogram is the base times the height. Working out the area of trapezium, you do half of the parallel lines added together and then multiply by the height. Or you can half the height and then multiply by the two parallel lines added together. So that's what our formula becomes then. What you also look at is another proof there, okay? What's the area of this triangle here? It's the base times the height. So B times the height and you half it. What's the area of this triangle here? That's the base and that's the height. So you turn half of A times H. So altogether we got the half of A times height and half of B times the height. So altogether we got half of the A plus B times the height. Okay, so same thing. Have a go at these three triangles. Pause the video and when you're ready, press play. Okay. Add the parallel lines and then multiply by the height and half it. Or half the parallel lines and then multiply by the height and then you get the answer. 5. This is the one that we can't half it beforehand, otherwise you can for majority of the cases. Okay, so what I want you to look at is, right, okay, so let's look at this one again here. We say this is A, the length there, and this is B. Okay, the same thing obviously goes for this one as well. So that's our trapezium and that's the height there. This is, by the way, 90-degree angle there. Okay, so if I take this another trapezium, same, exactly the same trapezium. Okay, exactly the same trapezium. And what I do is I rotate it and put it next to each other. I get double that, okay? So remember, up to that point, that was B. From here to there, that was our B. And what was this? Up to this point, this is our A. So that A will go there. So that's the reason we got A plus B. The total length there, or base, is A and B. And then we multiply by the height to get the area of the trapezium, okay? Sorry, area of this parallelogram. But this parallelogram is made of two different trapezium. So the area of this parallelogram is A at B multiplied by the height. So if I wanted to work out the area of one of these trapezium, okay, then I need to half that entire thing. And that's where that other half comes from. So add the parallel lines, multiply by the gap between them and half it. That gives you area. The last one, area of a kite, okay. So again, the kite is generally made up of two different triangles, okay. If you split that into that way, and then you got the two different identical triangles. That triangle is same as that triangle, okay. And I need to know the height of the triangle. So I can do that length, multiply by this length. That gives you the area of the entire kite. Why? Because you don't have to half it. You got true triangles already. And if you do the entire thing, let's say, this length, multiply that length, gives you the area of this rectangle. Excuse my rectangle, but that gives you, when you do this, so half the kite, area of the kite is half the product of this diagonal. So these two diagonal lines, multiply them together and then half it. That's the quickest way you can get there. Okay. So have a go at these questions if you want to quickly. Pause the video and when you're ready, press play. That's what we get. Again, don't forget the units, okay? Two things. Area is measured in small squares, centimeter by centimeter or millimeter by millimeter. Is the space inside any 2D shape, okay? And whenever you're doing these, make sure you remember what the units are and multiply the units by itself to give you those squares. So if the units are in two different things, then you need to convert them, change the units. So meter becomes centimeter or centimeter becomes meters, okay? And then the last thing, the height is always perpendicular, 90-degree angle to the base, okay? And so if you think you learned something from this video, you liked it, and someone could benefit from this video, make sure you like it and share it to anyone who can benefit from watching this video, okay? Thank you for watching, and I'll see you next session, next part, which is area and the circumference of a circle. Thank you.